All right, so in this video, what we're going to do is look at another container type in Python. In particular, we're going to look at sets. All right, so when I was first kind of learning Python, sets were not something that I kind of regularly went to, and it was only until much later when I kind of really recognized their power. I mean, that might very well be the case today. I mean, in future videos when we're looking at algorithmic things, we might be better posed to see the real power of sets. But today what I want to do is just really kind of differentiate them from list and show you kind of some of the unique things that they do, and hopefully that will kind of hint at some of the interesting use cases of sets. All right, so first off, what we're going to do is I'm going to make a list, call it my list. And one thing I didn't necessarily mention or focus on too much when we were talking about list in the list video is that you can definitely have duplicates of values in a list. So if we look at this, here's the definition. We've got essentially 1, 2, 3, 4, 5, 6, 7 elements. So that'll be index position 0 through 6. All right, if we look at the type of this thing, definitely a list. If we look at the length of it, 7 elements there, index position 0 through 6. All right, and if I print my list, it looks as we would expect, but we do have duplicates here of those 1s and those 4s. A set is going to be somewhat similar to a list, at least in how you define it. So let's actually define my set. Now, instead of using a square brace at the beginning, we're going to use a curly brace. So we're going to put this in a set of curly braces. Now, I want you to be really clear. We're going to see curly braces again when we look at dictionaries, but there's a very distinct difference, and we'll mention that at the time. But so here's my definition of a list. Here's my definition of a set. All right, so we define that. We can look at the type of my set. That's a set. Let's look at the length of it. There's only 5 elements. All right, so let's actually look at my set. So in this case, we got 1, 2, 3, 4, 5, which are correct, though we did have those values in here, but we don't have this extra 1 or this extra 4. All right, so that is the key differentiator for sets, right? You can only have, it's very similar to a list in the fact that it can be, it's a container for individual elements. However, the elements that it is composed of, you can only have unique values. All right, so you can't have 2 1s, you can't have 2 4s. Okay. So let's look at a few other things. So if you remember when we were in a list, we could do something like this, right? We could say, well, give me through, I don't know, index position 3. All right, so that doesn't work as well. So a set can't be subscripted, right? So we can't grab individual elements of that set. All right, and this is really kind of, when I first started using this, I was saying, okay, well, what are some use cases for this? Because it seems like a list is much more flexible. I can have a lot of, any type of data, even though I might have duplicates in there. But, it could be, there actually might be a lot of really valid use cases where you want to make sure that you don't have any of those duplicates, right? So maybe you're looking at your sales data and you want to figure out just the unique customers that are represented in that data. And so in that case, a list, you could have duplicates, but if you apply a set to that, you can immediately get that deduplicated. Let's look at an example of that. All right, so let me cut that out. And let's say, customer interactions. So I'm going to make a list. And this is just, imagine that we were just, maybe we have a website and we're keeping track of, customers that have interacted with our website in recent days. So maybe we got customer 1, got customer 2, let's say customer 3. And again, if this is just a log of interactions with customers over time, we might have customer 1 come back in. Maybe it was at this point customer 3, and then some customer 4, maybe customer 2 came back. And again, so imagine this is just like a sequential over time log of these customers that have interacted, and there's a lot of duplicates. Yeah, something like that. So again, maybe these are recorded at different times and we want to know how many unique customers interacted. Well, if you're using a list, that's not really easy, right? Because well, I had, how many interactions, right? I had, 9 interactions, but how many unique customers were that? Or was that associated with? But you can't really do that with a list. You can write code to go through and count, but it actually becomes pretty cumbersome. Well, instead, what you could do is just take customer interactions and you could just, let's see if it works with this syntax. All right, doesn't like that. So we can't make a set using just the braces, but you can also define a set using a function. All right, so this is how, if I've got a list, if I want to convert that to a set, I should be able to pass that in to this set function. All right, and we can see that those 9 interactions were associated with 4 customers. Okay. And it turns out that actually the speed at which this happens is very quick. So once we get a little bit, more capabilities behind us, and we've seen a few things with flow control, what we'll do is we'll actually use some of our flow control skills to build a comparison between sets and lists. And that's where we'll really see the big difference. The way that sets can identify those unique items or do lookups is extremely fast compared to a list. And if you, again, are working with very large data, you're having to do a lot of comparisons, specifically looking at differences between 2 different types of containers. Sets can literally save you hours or days. That's how much faster they are. So very nice thing to note. All right, so I'm just going to say this is going to be my customers. Right now, I'm just going to save that as, let's say this is unique customers. Great. So now I've got this set object. Just to show you how you can mutate. So if you remember, when we had a list, we had an append. We do not have an append. We do not have an extend for a set. So right now, unique customers, if I look at the type of this thing, that's a set. And you can always tell that when you print it, you've got the curly brace. Now, again, you're going to see curly braces with dictionaries, but there's going to be a very distinct difference. So the key thing with a set, it's curly braces and it's like individual elements, just like you would see with a list. All right, let me do a dot and hit tab. Here's the methods that we have available to us. All right, we can do an add. All right, so if we wanted to add a new customer, we can add customer 5 to our set. That's an in-place operation. So when I run this, I don't have to reassign it to the variable. So now we have customer 5. Okay. What if on another day, right? So let's just keep that in. So here's our unique customers. Let's say that we then are keeping track of this, and then on a different day, we have new interactions. And let's say that these numbers used, so we got customer 1, 2, 3. Let's change this one here to a 7, maybe a 6, and so forth. So let's say that, the thing that we had done, these customer interactions that we used to make that set originally, that was like a day 1, and then the next day we also looked at interactions. Right, so we got these new interactions, so let this be like day 2, right? So what we can do, all right, we got our new interactions right here, so this is our set. What if we wanted to figure out which customers are in this set that are not in this set? Okay, well, what you can do is you can take any one of your sets. So we got this, let's say this is going to be our new customers, right? Even though some of them aren't new, it's just a new day's interactions. So at this point, I've got this set unique customers. That was from our first day. And then we've got our customers from our second day. And we can see that this one doesn't have 5, right? New customers doesn't. And then, but it's got 6 and 7. What if we wanted to find the customers that were on this next day that we did not see on the previous day? Okay. Well, actually, this is one of the cases you can use a mathematical operator. All right, so I can say, well, take new customers and just subtract the set of unique customers. That was from day 1. I probably should have named that a little bit better. right? And you can say, oh, well, customer 6 and 7 are the ones that we saw on this day in this set that we didn't see over here. All right. What if we want to get the customers that we saw on both days, right? So maybe these are like our frequent customers. All right. Well, let's look. So if you're familiar with sets from, back in your days of mathematics, I'm not sure when you would have seen that. Maybe it was like an algebra 2 or something like that. But sets have an intersection operation where the intersection of two sets is basically the subset that contains the elements that are in common in both sets. So if I were to get new customers and do the intersection with our new unique customers, all right, then we saw customer 1, 2, 3, and 4, right? So remember, here's our day 1, so customer 1, 2, 3, and 4. And then in the new ones, we also saw customer 1, 2, and 3, and 4. So that is the ones that we saw on both days. And if we wanted to figure out all the unique customers that we saw over both days, instead of an intersection, we can do a union of two sets. All right, so here's all the customers that we have seen on either of those days. All right, so that's a little bit about sets. Again, we're going to look a little bit later, especially when we build up some capabilities with flow control. We'll revisit sets. Again, it's, the key thing to note, sets allow us to kind of quickly get the collection of unique elements in a particular container. They end up being very, very fast. And if you ever are in a situation where you've got like a container, you're trying to look up and say, well, is something in that container? If you have the opportunity to make that container a set, it's actually going to be, it can save you significant amounts of time. All right. Also, if you're looking at the differences between containers, like using this subtraction syntax, turns out to be very, very fast. And again, we'll see some specific examples of that when we do some of that flow control, get that behind us, that will really drive that home. And I think that is going to end our initial discussion of sets.